Parallel and perpendicular lines. So first let's remember from our geometry days what parallel and perpendicular mean. Two lines are parallel if they are equidistant apart, they'll never meet. Two lines are perpendicular if they cross at a right angle, a 90-degree angle. Okay, so these are basically you either have parallel lines, perpendicular lines, or lines that meet at some random angle. Those are your kind of three choices. And so because we're talking about slope and we're talking about writing equations of lines in this section, then it's important that knowing lines are parallel and perpendicular tells us something about their slope. So that leads us up here. Parallel lines have the same slope. Means their slopes, if one slope is 5, the other is 5. Whatever it is, they're the same. Perpendicular lines, which are lines that meet at a right angle, have slopes that are opposite reciprocals of each other. So opposite is talking about the sign. If one is positive, the other is negative. Reciprocal is talking about flipping a fraction. Okay, so for this first example, A, B, and C, we want to determine whether each of the following pairs of lines is parallel, perpendicular, or neither. But to start off, we need to solve them for y so we even know what their slopes are. So this is good practice for solving for y. On A, I need to move the 2x first, and that gives me 5y equals negative 2x plus 3. Then you would divide through by 5, and that gives you y equals negative 2/5 x plus 3/5. And all of that really matters is the slope here, negative 2/5. For the second line here, we need to start off by subtracting 4x. So that gives us 10y equals negative 4x plus 7. So you divide through by 10. You get y equals, if I simplify this, that's negative 2/5. And now we're ready to compare our slopes. So the slope on the first one is negative 2/5. The slope on the second one is negative 2/5. The other number, the y-intercept, does not matter. Since these are the same, on A we have parallel lines. And so you go through the same kind of process on B and C. So this first equation on B, it's actually trying to trick us. That's actually in y-intercept form. So if I just kind of rearrange it, see, I have y equals negative 3x plus 7. The second one, though, we do need to move stuff around. So subtract 2x, and we get negative 6y equals negative 2x plus 1. Then divide everything by negative 6, so that we get y equals positive 1/3 x minus 1/6. So let's compare our slopes. We have negative 3 and positive 1/3. Well, negative 3, if I make it a fraction, and I think about flipping that fraction, 3/1 flips and becomes 1/3. So that part is true. These are reciprocals of each other, and they're opposite of each other. This is negative, this is positive, which means these are perpendicular lines. By process of elimination, we can be pretty confident that this part C is probably going to be neither parallel or perpendicular, but let's just see it through. So to solve this for y, I need to get rid of the negative in front by basically changing all of the signs. So y equals negative 6x minus 4. For the second equation, I need to start off by subtracting 12x over to the right side. Sorry, I'm a little cramped on here. So then divide everything by negative 2. And I get y equals positive 6x minus 9/2. So if we compare our slopes, we have a negative 6 and a positive 6. Well, that might be like, oh, that's something, right? Well, they're opposite of each other, but they're not reciprocals. It's the same number, 6, but one is negative and one is positive. So this is still going to end up being neither as far as parallel, perpendicular, or neither. Now we're going to use what we've learned about parallel and perpendicular lines to write some new equations. It says write equations of the lines A parallel and B perpendicular to the graph of the line 5x minus 6y equals 12 and containing the point 5 comma negative 2. So the first thing we need to do is get the slope from this, and that requires us to solve for y. So I'm going to subtract 5x from both sides and get negative 6y equals negative 5x plus 12. Then divide by negative 6, which is y equals positive 5/6 x minus 2. Now, what I need from that is just the slope. The slope of our equation they gave us is 5/6, which means that for A parallel, I'm going to use that 5/6 as well as the point 5 comma negative 2. And then for B, I need the opposite reciprocal. So instead of 5/6, I'm going to do negative 6/5. And I'm still going to use the point 5 comma negative 2. So let's use point slope form. Y minus a negative 2 means y plus 2 equals 5/6 and then x minus 5. We can simplify that. It's not going to be particularly pretty. There's going to be fractions involved. So you distribute right here first. Get 5/6x, and that'll be negative 25/6 because you multiply the 5's together and then the denominator is 6. Then to subtract 2 from both sides, you would either go emergency, pull out your calculator, or negative 2, I need a common denominator, so I'd make this negative 12/6. And then that gives me negative 37/6. So that's not particularly pleasant, but because of the fractions, but oh well. For part B, let's do point slope. So it actually looks the same except for where the slope is different. Which is actually good in a way, because when I distribute here, I do get rid of a fraction. This is negative 6/5 x, but then this distributes and becomes positive 6. And then I subtract the 2 over and get y equals negative 6/5 x plus 4.